So this is the Chapter 2 practice test. Brace yourselves, this is kind of lengthy. Okay, so identify the vertex and intercepts of the graph of this. So my thought, first off, would be to find the vertex, which would involve using the first part of the quadratic formula, so the opposite b over 2a. So that would mean the x-coordinate is at -5/2. So then I plug that in. Right? So this becomes 25/4 plus a -25/2 plus 6. Now I'm going to put this all over fourths, which means I need to double this, minus 50/4, and this becomes 24/4. So 25 minus 50 is -25, plus 24 is, let's see, -1/4, which means that the vertex is at -5/2 in the x, -1/4 in the y. Now the zeros, or they call them x-intercepts, same thing, right? What times what is 6, but adds together to get 5, plus 2, and plus 3. So the x-intercepts are at, or this would be -2 and -3, -2, 0, and, because technically they're fishing for coordinates here, -3, 0. Standard form. Standard form is also known as vertex form. So I know there's some vertical stretch, and I'm going to have some sort of shift of the vertex. In fact, it's shifted right 3 and down 6. That's reflected there. So then all I do is I plug this point that I know, the y-intercept, in. Simplify. -3 squared is 9a. Add 6. Divide by 9. And after all that work, you get 1, which means that the final equation would be just x minus 3, 180 squared minus 6. That's it. Find all the reals and zeros of this. Determine the multiplicity of each 0. Okay. So looking at this, I can at least pull an x out. So that means I got one of my zeros, right? So it's 4x squared minus 12x plus 9. I can't pull anything else out, so I'm just going to go ahead and boldly try to factor. Let's go with 2x and 2x. And if I got 9, let's go with 3 and 3. Because 2 times 3 is 6, 2 times 3 is also 6. And when I make them both negative, that means I'm looking at a cubic, right? That's a cubic. That has 1 0. So it has a 0. Zeros are, there we go, x equals 0, and that's multiplicity 1, it's only happening once, and x equals 3/2, add 3 divided by 2, multiplicity 2. Okay. Sketch a graph of this function. So sketching a graph of this function involves, well, frankly, what I'm going to do is I'm going to have to try to kick a stab at a root. So I'm going to go ahead and try -1 as a root. So the key thing here is, without a graph, I'm not expecting you necessarily to do this. So therefore, sketching a graph of this without this is kind of a perplexing notion. But if you think about it, then I have ±1, ±2, ±3, ±6 is all the factors here, and this is just ±1. So it gives me different numbers I can check. So if I were to do a synthetic division, I should be able to get down to something manageable. I'm just kind of taking an educated guess here. So this is -1, 0, 7, and 6, because there is no x squared term. I pull out a -1. It turns out that's a 0. So that means one of the roots is x plus 1. One of the factors is x plus 1. And the rest of the equation is -x squared plus x plus 6. So I can factor that. We'll pull a negative out. It becomes x squared minus x minus 6 minus x minus 6. Then I can factor that. And that'd be a minus 3 and a plus 2. That'll get us the right difference. And that way, when we're sketching the graph, we know that this is negative, so it's going to start here and end down here. It's going to have zeros of multiplicity of 1 at 3, negative 1, and negative 2. So it's going to go down, up, down, like that. Divide using long division. Key setup here, x squared plus, don't forget the zeros for terms that aren't there. Same here, 2x cubed plus 0x squared plus 5x minus 3. This actually is pretty straightforward. X squared times what is 2x cubed? Well, 2x. Don't forget to line that up over the x term. Then you distribute. 2x times 2 is 4x. And you subtract the whole mess. Gone, gone, x minus 3. X squared does not go into x at all. So the actual solution of this divided by this is 2x plus the remainder over what you're dividing by, quotient. So that would be a good final answer. Divide using synthetic division. Key thing here, well, two key things here. Don't forget to fill in zeros. 0x cubed, negative 5x squared, 0x minus 3. And when you're dividing by this factor, the actual root is 2. Now, once you're there, that means that the remainder is 9. So your answer is, remember this is fourth divided by a single, so it's 2x cubed plus 4x squared plus 3x plus 6 plus 9x minus 2. So that would be the formal answer for that division. Okay. Use synthetic division to evaluate. So all I'm going to do is take and write this out. 0x cubed minus 6x squared plus 5x minus 1. And I'm going to divide it by negative 2. And my remainder is going to be the answer. So f of negative 2 is going to be whatever this remainder is. So bring this down, multiply, add, multiply, add, multiply, add, multiply. So that works out to be 13. F of negative 2 is 13. So list all the possible rational zeros for this function. Use a graphing utility to graph the function and find all the rational zeros. So unfortunately, that means you need to list all the factors of the lead coefficient, which is easy, as well as the tail coefficient, which is not so easy. So it's plus or minus 1, plus or minus 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And that actually covers it. So then you take all of these and you divide it by these. So that's actually pretty straightforward somewhat. But it means you're going to get plus or minus 1, plus or minus 1/2, right? Plus or minus 24, 24 divided by 1, plus or minus 12, 24 divided by 2. Plus or minus, well, 2 divided by 2 is 1. We already have that. Oh, no, we don't have that. I'm sorry. Plus or minus 2 divided by 2 we do have, so we don't need to repeat it. Plus or minus 12 divided by 2 is 6. Plus or minus 12 divided by 1 we already have, so we don't need it. Plus or minus 3 divided by 1. Plus or minus 3 divided by 2, or 3/2. Plus or minus 8 divided by 2, which we don't have. Plus or minus 8 divided by 1. Mess, eh? Plus or minus 4 divided by 2, we already have. Plus or minus 4 divided by 1, we already have. Plus or minus 6 divided by 2, we already have. Plus or minus 6 divided by 1, we already have. Okay, so it's not as terrible. Those are all the possible ones. So then what you do is you go through and you do what I did. And you pick one and you divide and you hope. Now, it turns out that you could also graph these. So if you use a graphing utility, we look at something like this, right? There's our function. You can see negative 2 and 1.5, aka 3 halves. So negative 2 and 3 halves. So what I'm going to do, and it looks like it did, is I'm going to take this thing, 2, negative 3, 0, 16, and negative 24. And I'm going to divide it by negative 2 first. So that's going to be 2. Negative 4 for negative 7, 14, negative 28, which is negative 12, and 24, which is indeed, right, what we hope for. So that would mean we have one factor out. Now the other one, that 1.5, you have to think of as a fraction. That's going to be 3 halves, or you can do 1.5, I suppose. That doesn't make a whole lot of difference. 3 halves times 2 is just 3. So negative 4 times 3 halves is negative 4 divided by 2 is negative 6. That's 8. 8 divided by 2 is 4 times 3 is 12, which means the remainder is 0. So here's what we got. We've got a bit of a mess here. We've got x plus 2, because that's what this factor is, right? X plus 2. This is x minus 3 halves. X minus 3 halves. And then this is 2x squared minus 4x plus 8. Now if you check this discriminant, this is 16 minus 4 times 2 times 8. So that's actually the final factored form. You can't pull anything else out. Now if you wanted to pull the 2 out and put it here, and that would mean x squared minus 2x plus 4, but this is fine for factored form. So this is not as bad in terms of listing all the possible rational zeros. It's plus or minus 1, plus or minus 3 for the factors here, plus or minus 1, plus or minus 2. So the possible zeros would be 1 divided by 1, or 1, 2 divided by 1, or 2, 1 divided by 3, or 1/3, and 2 divided by 3, or 2/3, positive or negative, remember. Okay? So then we resort to our graphing utility again, and we discover that we are looking at this, which has roots at -1, something, and +1. -1, -2/3, and 1. Okay? So then they want us to do what? Use graphing units to find all the rational zeros. So it turns out that these zeros are at -1, I forgot, -1, +1, and -2/3. -2/3 and 1. And those are all the rational zeros that you get, because the rest would be complex or imaginary. All right, find all the zeros of this function and write the following numbers as a product of linear factors. Okay, there's 2 ways to go here. One is to take a wild stab at what you think the roots might be and then divide. Or you could take a look at the graph. I'm going to go the wild stab route, 19 and 1, right? So I'm going to go with plus or minus 1. So we'll try 1, so -7, 11, 19. Let's try dividing that by 1 and see what happens. 1 times 1 is 1, so that's -6. So that's -6, and that's 5. And that does not work out because it's not going to cancel, so it's not a 0. Let's go for the other low-lying fruit because I don't think 19 is going to work out. Try -1. -1, -8. 8, 19, -19. And there it is, campers. So we know that we're looking at x plus 1, because remember this is as a factor x plus 1, right? Times x squared minus 8x plus 19. Okay. Now, it turns out that this thing is, well, you'll see, it's problematic. It does mean that this is a quadratic, the discriminant is less than 0, but it says find all the zeros without any sort of limitation, so not just rational. So that means that we have to use the quadratic formula, opposite b over 2a, plus or minus, we know this is going to be over 2, 8 squared is 64, minus 4 times 1 times 19, 4 times 19 is 76. And sure enough, we're going to get complex roots, right? So this is 4 plus or minus negative, the square root of -12 over 2, or 4 plus or minus the square root of 12 over 2i. Now, please bear in mind that you could reduce this 4 times 3, which means you end up with 2 square root 3 over 2, or square root 3i. So all the roots would be, the zeros, right, would be -1, and then 4 plus or minus root 3i. You can list them like that. The factored form would be this. Notice the parentheses, and then that. So that would be the factored form of that. 11, perform the following operations. So real with real, -8 minus 1, -9, -3 minus 15, -18i, and done. Ooh, 10 plus, what's root 20i? Why, it's root 20, or sorry, root -20 is root 20i, minus 4 minus root 14, so it comes to be root 14i. Now, this is reducible. This is 10 plus 4 times 5, or 2 root 5i, minus 4. This is not reducible. Okay, so we've got ourselves in a bit of a quandary here. So we solve this by, well, 10 minus 4. That's easy, that's 6. 2 root 5 minus a negative, so plus root 14. Plus 2 root 5 plus root 14i. Okay, not too much of a quandary. A mess, but not too much of a quandary. All right, multiply. 2 times 6 is 12. 2 times -i is -2i. I times 6 is plus 6i. I times I, positive I times negative I is -i squared. So 12 plus 4i, -i squared minus -1 becomes plus 1. So 13 plus 4i. And that's it. Same idea here, except we have to square it. So this is 4 plus 3i times 4 plus 3i minus 5 plus I times 5 plus I. You got to be careful on this one. Okay, 16 plus 12 plus 12 plus 24i plus 9i squared minus 5 times 5 is 25. 5 times I, 5 times I, plus I squared. Notice this subtraction in the parentheses. So, 16 minus 9, because that's a minus I squared, right? So it changes sign. 16 minus 9 is 7 plus 24i minus 25 minus 1 is 24 plus 10i. So 7 minus 24 is negative 17. 24 minus 10 is 14i. That's your final answer. Okay, write the quotient in standard form, meaning they want you to get the I out of there. So what's the reciprocal of I? Opposite I. So I times I, that's negative I squared, aka 1, right? Negative 1. This becomes negative 8i plus, negative, right? Negative 5i squared. Negative 5i squared is positive 5 minus 8i. So this is 5 minus 8i, written another way. Here they are again. They want you to divide, so you're going to multiply by 2 plus I, top and bottom. Now in this case, because they're conjugates, you could do this as 2 squared plus 1 squared, or 5, right? 5 times 2i is 10i, plus 5 times I, 5i times I is 5i squared. Okay, so this is negative 5 over 5 plus, right, 10 over 5i, or negative 1 plus 2i. Well, they're trying to throw you by using a sign that you might mistake for subtracting, but you're not going to, I hope. So you're going to multiply by the conjugate. Ooh, 3i plus 2. They fooled me. I'm going to rewrite that in standard form. See that? 2 plus 3i. Trying to get me. 2i minus 1. Let's rewrite this whole darn thing. So negative 1 plus 2i over 2 plus 3i. I'm trying to be annoying. So then 2 minus 3i, and then 2 minus 3i. So 2 times 2 is 4. And so we're going to do 2 squared plus 3 squared, which is 13. So we're going to get 13. This is going to be a bit messier. Negative 2 plus 3i plus 4i minus 6i squared. So negative 2, that's a plus 6, is going to be 4 over 13. 3 plus 7, 3 plus 4 is 7i, and it's positive 13. That's it. Solve the quadratic equation. X squared equals negative 54. And before we take a breath, we take the square root, which is the square root of 54i. 54, that's a good one. I can pull a 2 out and I get 27. I don't think I can go any farther than that, can I? So, x, now the one thing I did forget, plus or minus. So x is equal to plus or minus the square root of 54i. That's it. Here, because it's quadratic in standard form and has a b term, x equals opposite b over 2a plus or minus b squared, which is 4, minus 4 times this, so minus 32 over 1. So this is 2 plus or minus the square root of negative 28i, or 2 plus or minus, square root of negative 28, I got ahead of myself. 2 plus or minus the square root of 28, which is technically 4 times 7, so 2 root 7i, right? 19, sketch the graph of the rational function. As sketching aids, check for intercepts. Now, personally, what I would do is recognize that 4 over x squared is an x squared model that's been vertically stretched by a factor of 4, right? Remember the x squared model, that looks like a smokestack, but it's also been shifted down 1. So that means it's going to level off at negative 1 instead of, right? Okay. Now, one way to look at this is, when is this thing going to hit 0? So that would mean you'd have to multiply this by x squared over x squared, right? So you got 4 minus x squared over x squared, which means it's going to have a vertical asymptote at 0, right? It's going to level off at negative 1 because highest power, right? So we got that. And we also know 4 minus x is quantity squared. Well, that is the same as what? If I factor it, 2 minus x times 2 plus x over x squared. So it tells me that the zeros are going to be x equals negative 2 and 2. Vertical asymptote is going to be x equals 0. There is a horizontal asymptote, as we discussed. That's at y equals negative 1, which is also the end behavior. Y-intercept. If I plug 0 in here, it blows up, so there is no y-intercept. Okay. All right, this one's a little bit trickier. Now, zeros. X squared plus 2 never equals 0. You can't take the square root of a negative number. However, there is a vertical asymptote at x equals 1, right? And the y-intercept, if I plug 0 in here, the y-intercept is going to be equal to, what is it going to be equal to? 2 over negative 1. So it's going to be y equals negative 2. Oops. Horizontal asymptote? No. But there is no oblique asymptote. So what does that tell me? It tells me that I'm going to have x squared plus 2, or 1, 0, 2, and I can do synthetic division because this is a linear factor, as long as it's divided by 1, right? 1 times 1 is 1, 1. I don't even care about the result here, but that's x plus 1. So the oblique asymptote is x plus 1. So what does that mean? It means I got my graph. It means I've got at x equals 1, I got vertical asymptote. I've got a y-intercept, where to go, of negative 2. So it's got a y-intercept of negative, so that's it. 1. At negative 2, it's going to cross. Is there anything else that I need to know? I know it's going to end up here. So it's going to end here and here because it's got a positive slope. So I would argue that this is going to look like this. And because it's crossing through here and it's never actually touching, it's going to go, right? Doesn't have any zeros. That's it. Sketch the graph of the rational function, blah, blah, blah. That's sketching aids, check for intercepts. So, zeros. When is 2x squared plus 9 equal to 0? The answer is never. That's sad. Vertical asymptotes. It gets better. When is 5x squared plus 2 equal to none? Horizontal asymptote. Highest powers, 2/5. Y-intercept. Y equals, well, if I plug in 0, 9/2 or 4.5 if we want to go that route. Unfortunately, that's all we've got. So it's got to have a y-intercept of 4.5. It's 4.5. It's got no, I repeat, no actual, it's got a horizontal asymptote 2/5. It's going to level off down here, right, like that and that over the long haul. And then it's going to be 4.5. So maybe it looks something like that. That'd be my argument. Not a fun looking way. And that actually concludes the chapter test. I'm sorry to say, but that's it.